They call this the cosmic trio of Auriga. You have a spider, a fly, and two massive cosmic tadpoles, all fighting for attention in a sea of ionized gas. Between November and January, I spent 7 nights and nearly 20 hours capturing photons from this region. Today, I'm taking you through the geology of these nebulae, the gear that tracked them across the frozen Swedish sky, and the PixInsight workflow that revealed them. My name is Morten, and you are watching Frosth Astrophotography. Let's break down what we're actually looking at. First, on the upper right, we have IC 410. It's about 12,000 light-years away. See those two wiggly shapes? Those are the tadpoles. They look small here, but they are 10 light-years long. To put that in perspective, that's twice the distance from Earth to the nearest star system. They are being blasted by the radiation from the cluster NGC 1893. Basically, they are eroding in real time. Then over to the top left, we have IC 417, the spider. It's closer, about 7,500 light-years away. The legs of the spider are actually dust lanes being carved out by the young cluster Stock 8. The cluster contains massive blue OB-type stars. On the bottom left, we have NGC 1931, the fly. Roughly 7,000 to 10,000 light-years away from Earth. It's a compact mix of emission and reflection nebulae, a miniature Orion nebula, if you will. Visually, it is paired with the spider. They form a cosmic predator-prey scene, though they are light-years apart in reality. To capture this wide field, I used my trusty SkyWatcher EvoStar 80ED with the 0.85x reducer. Together with the new Poseidon-M Pro camera, it gives me the perfect focal length to frame all three objects. Since this is a narrowband target, I used the Player One S-Series 2-inch SHO filters in the Phoenix filter wheel. Data acquisition was a marathon. 241 exposures in total, 70 frames of sulfur, 101 frames of hydrogen alpha, and 70 frames of oxygen. The hardest part? The weather here at 63 degrees north. I had to grab these 20 hours in pieces between November and mid-January. Here we have the data for the tadpole, the spider, and the fly. The tadpole up here on the right, the spider to the left here, and the fly here down in the bottom left. This is 20 hours of data, 241 frames, 70 each of the S2 and O3, and 101 for the H-alpha here. The linear processing steps for this image were as follows. Starting with a dynamic crop. I always do that to eliminate stacking artifacts in and around the edges, corners of the image. Even though you might not see them, you have to really zoom in to be able to see them. And why is that important? Well, first of all, it might visually impair the image. And second of all, when you are doing the background extraction or dealing with gradients as a step 2, those stacking artifacts might disrupt that process, and they might do it in a very bad way. So please check and do a small crop of your edges. Then I ran through the automated dynamic background extraction. Not that big of a difference. Then I ran through the blur exterminator and noise exterminator as I usually do, giving me an image that looks like this to start with. I'm fairly happy with the results here. I don't have any big halos around the stars. This is the H-alpha filter, I might say. And I can clearly see the tadpoles up here. Let's compare it to this image here that has none of the background extraction or blur and noise exterminator. So it's a big difference, I would say. I then ran through the star exterminator, giving me a result, a starless result here. This is a screen stretched, of course, but a starless result of the H-alpha. And yes, this is 101 5-minute light frames. So I have a lot of data in this image. I would not be happy if this data with 101 5-minute light frames and this Poseidon-M Pro camera didn't give me a good result, even with my ED80 double glass telescope. The new combination, if you compare to the old, the ASI 294 Pro camera, gives me a bit bigger picture. I could fit all of these 3 objects in the image here without any problems, and the old combination would not have allowed me to capture these 3 in the same image in this way. So I'm happy about it. You can see that you have a lot of nice structures out here, a lot of hydrogen alpha data in the image, so it's going to be nice to process it. I also processed the other 2 filters, of course, in the same manner. I'm going to show you them in screen stretched as well. This is the Oxygen 3. Not as much data and not as clean, but there aren't that much Oxygen 3 in this other than in the actual regions here of the nebulosity. And checking the sulfur 2, there is a lot of sulfur 2 here. And I really like to add sulfur 2 because of the structures of the filaments here, complementing the hydrogen alpha, giving this an interesting look. To not bore you too much, but still show you the actual processing in the linear phase, including the stretching that I did with generalized hyperbolic stretch, I'm going to show you a time lapse of the whole process now. So enjoy that, and then we will dive into the non-linear phase. Starting with the stretched versions of H-alpha, O3 and S2, I tried to stretch these as much as possible, but I've also tried to adjust the black point and given it as much contrast as possible. I had to try different stretches and combinations before I chose this level, just to get a starting balance in the RGB red, green and blue channels in the color image. So the H-alpha here, the O3 here you can see, and the S2 starless version here. A lot of stretching going on in these areas here, but still trying to keep the contrast here. I added these three together to make this initial starless version of SHO. And you can see that you have a lot of colors. There's a very strong signal in the S2 here, and the H-alpha, of course. And this is where the struggle began to color correct this image, giving me a starting point to move further with the starless processing of the image here. You can see that there are magenta parts here that you really don't want to have in the image here, and also down here with the fly. So after some long corrections with color, I ended up with this version of the first step in the non-linear phase. This is the initial color correction. I have adjusted all of the colors, removing magenta. I have tried to get the blue out of the image here. I wanted to have the SHO golden feel to all of this H-alpha nebulosity, and I have boosted the saturation and vibrance a lot in this image, trying to get to here without overblowing the areas here. So the next step was to run through some sharpening. As always, I tried to simply make the sharpening very subtle. If we are comparing these two here, you can see that there is some sharpening, but not an extreme amount. So that's something that I'm happy with. The next step, I ran through some noise removal, and there were just some slight noise. I don't know if the YouTube compression allows you to see this, but you can see that there are some noise in the darker areas here. And I simply ran through Noise Exterminator again, and that took care of these dark areas. Then I did my normal synthetic luminance. I extracted from this a luminance, and then I did some processing on that, some local histogram transformation and some sharpening. Then I added that synthetic luminance back into the image, giving me some extra sharpening and contrast on these areas up here mainly. You can see on the ridges here and on the details here in the nebulosity that we have achieved some extra sharpening, and I really like this step. I don't skip it. And sometimes I use the H-alpha for this step, and sometimes I simply extract the luminance from the step before. Depends on how strong and balanced the three filters are, because it could affect the colors a lot. And as a last step here, I adjusted the colors again. I also added some extra contrast, this time over the whole image, a slight S-curve using the curves transformation on the image here, giving it a little bit more boost, I would say, in preparation for the final step. For the stars, I joined the SHO stars together, stretching them individually, of course, like I normally do. I then ran through Image Solver on the image there, and then I ran a spectrophotometric color calibration on the image there, making a synthetic RGB star, trying to get those natural colors of the stars here without actually capturing RGB data. And I haven't stretched the stars so much here, as you can see, because I like to try and have the stars not overpowering my main subject, in this case the three nebulas in this image here. So after the joining of these images together here, I ended up with this image. There you have it, the cosmic trio in Auriga, Tadpole, Spider and Fly. 20 hours worth of collecting data, putting it all together in an SHO image. Enjoy this one, and I will see you again soon. The depth you can get with the EvoStar ATED never ceases to amaze me. If you are planning to shoot this target, Give it time. The O3 signal here is faint, but it's worth it for that blue contrast against the golden hydrogen. Thank you so much for watching this video, and if you like it, please give it a thumbs up and consider subscribing if you're not already doing so. Until the next video, I wish you have clear skies.